Hi, my name is Craig Einstein. I'm an R&D scientist and engineer at ARiA. During this presentation, I'll be discussing the Universal Sensor Definition Schema, which is being developed for NAVSEA topic N19B-T035. ARiA is a small business that is comprised of research scientists and software engineers that provide broad interdisciplinary experience with greater than 60 years of collective experience in signal processing, greater than 35 years of collective experience in software development, and greater than 25 years of collective experience in machine and deep learning. What makes ARiA unique is its laboratory-to-field pipeline, where bleeding-edge research is integrated into fielded systems. Its team combines active world-class researchers with experienced software and systems engineers who have fielded systems for DoD and for the commercial sector. And ARiA offers the lowest indirect rates in the entire industry, meaning we can get more done, better, faster, and for less. The objective of topic N19B-T035 is to develop a universal sensor things application programming interface, API, that enables systems to utilize data from all current and future sensors without requiring new development. Its acquisition program is PEO IWS-5, AN/UIQ-100 Undersea Warfare Decision Support System, USDS Program Office. Its technology area is information systems. The topic requirements are to develop an innovative implementation of a universal sensor things API, have that implementation be scalable, to leverage open source technologies to construct a reusable API, and to support heterogeneous types of data. This topic seeks to streamline the integration of sensors into applications and systems. To achieve this objective and to satisfy the requirements of the topic, the Universal Sensor Definition Schema, or USDS, was created. The AN/UIQ-100 USWDSS is the primary target for USDS, but other platforms that receive and process sensor data are also potential targets for USDS. Current sensor integration is costly. It incurs costs through large developmental overheads through redevelopment and reimplementation, and has potential sources for implementation errors and other bugs. USDS eliminates the need for reimplementation and thus reduces potential sources of overhead and error. USDS is a translation pipeline that generates immediately usable source code in a language of the developer's choice. It's comprised of three main components, each of which can be seen in the diagram at the bottom of this slide. The first component is the USDS programming language. The USDS programming language was designed specifically for USDS and uses a lightweight yet expressive and familiar syntax to describe data and common associated functionality. The second component is the translator. The translator translates descriptions written in the USDS programming language into an intermediate representation. The third component, the generators, take this intermediate representation and generates usable source code in a language of the developer's choice, and also produces associated documentation. In the diagram at the bottom of the slide, you can see the delineation between the components that would be used by sensor producers and those that would be used by sensor consumers. Sensor consumers are those developers of applications and systems that wish to integrate sensor data. The sensor consumers would receive a script written in the USDS programming language written by the sensor producers, run it through the translation pipeline, and receive immediately integratable source code in the language that they specified. USDS is just entering TRL 5. The project is in Phase 2 base, and its period of performance is from February 16, 2021 to February 17, 2023. There are 5 major milestones planned for this period of performance. The first is the development of the initial USDS implementation. The measure of success for this milestone is the demonstrated USDS capability of translating USDS programming language scripts into a variety of commonly used programming languages. The status of this milestone is complete. The second milestone is the enhancement of the USDS implementation for a transition prototype. The measure of success for this milestone is the support of additional features that are necessary for transition. This milestone is currently in progress. The third milestone is to ensure that all ACDM structures and features are supported. The ACDM is a document that contains data structures that are frequently used within the USDS. The measure of success for this milestone is that all structures in the ACDM are capable of being supported and translated by USDS. This is currently in progress. The fourth milestone is an alpha prototype delivery. The measure of success for this milestone is the software handoff for measurement and testing. This is planned for Q2 fiscal year 2022. The fifth milestone is a beta prototype delivery. The measure of success for this milestone is that USDS successfully integrated into USDS and is able to support all the required features. This is planned for Q2 fiscal year 2023. The following table describes the key features for USDS. The first key feature is the USDS programming language. The advantage of this feature is that it provides a lightweight and expressive syntax to describe data and functionality. The benefits are that it allows sensor data and functionality to be described and also supports several other useful features, such as the ability to automatically generate a parser function for the defined data structures. The second key feature is the USDS translation pipeline. The advantages of this feature is that it performs syntax checking for the USDS programming language and is also able to convert the input USDS programming language script into an intermediate representation for source code generation. The benefits are that it ensures the USDS programming language input is well formed and also allows for the conversion of the input script to any programming language. The third key feature is the USDS code generators. The advantage of this feature is that it's able to generate code in multiple programming languages. The benefits are that it's able to generate immediately usable source code, and it's also decoupled from the translation pipeline, allowing for independent development of the language generators. This allows for new output language targets to be integrated into USDS in a straightforward manner. The fourth key feature is the USDS generated source code. The advantage of this is that it's straightforward to integrate and use with existing code bases, applications, and systems. The benefit is that it's immediately usable and it's able to be integrated into existing projects. The fifth key feature is the USDS generated documentation. The advantage of this is that developers do not have to parse generated source code to inspect the output generated code. The benefits are that it precludes developers from having to open the source code, and it's also able to generate visual aids such as dependency graphs. The transition plan for USDS is that it is to be integrated with USWDSS Build 3 AN UIQ100 Undersea Warfare Decision Support System. It is meant to enter into the USWDSS Quarterly Agile Functionality Drop Cycle. The target transition date is Q2 fiscal year 2023. The sponsoring program is NAVC PEO IWS 5E. USDS is taking certain steps to mitigate the risk of transition. One is the testing of USDS using ACDM 3.5 definitions. And also, USDS is designed to be incrementally integrated, allowing changes to be made efficiently. The primary goal of USDS is to be sold directly to the Navy for the integration with AN UIQ100 USWDSS. We can work with Navy, other DoD agencies, and primes to license USDS. Any platform that ingests and processes sensor data is a target for USDS. USDS can be a service that agencies and industry can use. For example, sensor data and functionality descriptions written using the USDS programming language can be uploaded to a central service, and usable source code can be returned. The primary commercialization target is the integration of USDS into command and control systems, tactical systems, and TDAs, or tactical decision aids. USWDSS prime progeny is a target for USDS licensing. USDS also intends to become a sensor interfacing standard, which is useful for TASW communication. Lockheed Martin is another potential licensing target. Lockheed Martin is an integrator for SQQ-89 and BQQ-10 ARCI. Thank you very much for listening to this presentation. And please come talk to us. The points of contact to follow up are Dr. Jason Summers, the Chief Scientist at ARiA, and myself, Craig Einstein. Thanks again.